Okay, so going back to our previous progress of the game, we have the player. We have sort of like a rudimentary level with colliders, etc. But we have a few things missing. Especially we don't have the jump, right? We can move around. Sorry, move around. We don't have the jump yet though. But we already have collision with the platforms. You have the background. We also don't have camera movement. So if I go out of the screen, then well, there, camera doesn't follow. So we'll do that. There's also one thing here. If you've noticed, if I move A and D while I'm in the air, say I'll go here. If I move A and D while I'm in the air, it kind of floats or hovers. And then if I release, then our character falls. That has something to do with the code that we did last time, but we'll fix that today. Okay, so let's do jumping for now. That's easy to implement yet. Yes. Uh, so we'll edit the script, player movement scripts out of it. Okay. So jumping, just as easy as we did in MP3, right? This is just, I'll do a method here, void a player jump, and we'll just add some force to our uh, rigid body, right? So we do rigid body player.rb, add force. My IntelliSense is not yet kicking in. This is vector 2.up. Okay. We multiply this with, oops, that's all right. Okay. We'll also serialize a field here for jump force. Jump force here. Okay. So we can edit it on the fly later on. So vector2.up times jump force, and then the force mode is force mode 2D dot impulse. Okay. And then we'll call this whenever we have input for jump. I'll just use the input manager here um, for the input. Let's just double check what key is the jump bound to. Okay, wait. So we go to edit, project settings, uh, where is it? Input manager, and we'll use the jump axis. So name is jump, positive button is space. So if we have an input, oops, we have an input dot get button down, uh, jump, then we just say player jump. Okay, so let's do that and let's compile. Okay, go into play mode. Okay, it's moving. So our jump here, it's a bit okay, but right, it falls a bit slowly. So for the if it falls a bit slowly, you can edit the gravity scale for rigid bodies. For rigid body in the 3D environment, I don't think we have gravity scale for each individual rigid body, but for the 2D space, we can edit the gravity scale for each game object if it has a rigid body. So if I put like 3 here, so the specific gravity for the player is changed, but the gravity for the overall game is not. Okay, so for this, I think 3 is pretty good enough, but we will tweak our jump force, maybe around 15 or maybe around 12. So it could jump. That's a good jump and that's a good falling time as well. But there's a problem here. When we go down, it's still doing that thing where it floats. We'll see which part of the code that is later. and we can jump mid-air as well. So the things we want to do here is to fix this thing where if we go from side to side, we're hovering, and when we are in the air, we're still jumping. So let's do some collisions for that. So first we'll do the side-to-side fix. That's easy enough. The source of that is this line of code, 35, line 35, where we are editing the velocity of our game object with our horizontal input times the move speed. That's not the problem here. The problem is we're zeroing out the velocity on the y-axis. So when it is falling, when you press A or D, whenever we get that input, we try to make that the y velocity is 0, right? So that's why it's hovering down, like so. So what we want to do is we want to preserve the y velocity of our game object. So we do player rb.velocity.y. So we're saying that we're editing the x velocity, but we are not doing anything with our y velocity. Okay. Okay. So let's play. Okay. So we're jumping, and if we fall, we're falling with the correct speed. But we're still flying whenever we press on jump. But it falls correctly now. Okay. There's another problem here where if you stick to the wall, there is collision happening and there is friction preventing you from falling down. We'll also fix that in a while. Okay. But we'll do the double jump fix first, no? Because we don't want to be jumping midair. For that, we have currently our player only has a collider, right? One collider that collides with the ground or the platform. So if we jump, we can trigger our is on ground whenever we are touching a collider from the ground. However, there will be a problem, for example, if you collide with a wall, right? If we limit our collision to the ground and our platform is all tagged ground, when we have this collision, we are not really on the ground, but we are colliding with a wall, which is also tagged ground. So that will give us another sort of like is ground status, right? What we want to do is we want to have a detection where only the feet is on the ground, right? But the sides do not collide with the ground. For that, we can do another collider, but this time we'll just set it as a trigger. So we'll go to our player. I'll add a collider, box collider 2D. I'll just move this up uh, so it's a bit um, organized. And then we'll click our main collider to edit. But we won't edit our main collider, we will edit the other collider. It's hard to see because it's green on green. But here I'm moving it here a bit to the center, right? Okay. Okay, so the width of this is slightly smaller than our the width of our collider or our exact collider. This trigger should not be triggered when we are bumping into a wall, right? So we're hiding it there, and then it's only like on the bottom when we are stepping. Okay, so that's good enough. But this collider will not be an actual collider. This will be a trigger. So we'll only set no if this trigger hits a wall or detects the ground. Okay. Let's okay. So let's have a boolean here where it's like a status now. Is the player on ground? Is the player off the ground? I'll just put one private bool is on ground. Uh, I'll initialize this to true, just but we can uh, yeah. And then I'll just make a setter for this. So click here. So public void set is on set set is on ground, which accepts a bool is ground. So we encapsulate our is on ground, and then we say this dot is on ground. So we're referring to the object variable and not the parameter here. So we're taking this parameter to the object variable. And then I'll create another script for just for collisions. So we can modularize the collisions and the movement. It's not just in one big script. Okay, I'll do another script, layer collisions. And then we'll add this to our player. Okay. And we'll edit the script. So we should have a reference to our movement. So we could set our is on ground. Or you could have another script no, that would contain all the just the states or gates, booleans, is on ground, is crouching, etc. If you have that. But for now, we'll just do it in player movement. We could sort of refactor that later on. I'll do private player movement, and then we'll just take the reference at the start, get component, player movement. Won't need update here. What we need is on trigger enter 2D. So it's important if you're in the 2D environment that you would also have 2D trigger enter and trigger exit, etc. Collider 2D other. Okay. So we could say that if say other dot tag, or we could actually compare tag this with the ground. So say we have a trigger enter with the ground. We can say then that our player movement dot set is on ground is not false, true, right? We're colliding with the ground. And then we could have another function here or another method here for exit. So on trigger exit, so when we don't have any more collisions with the ground, we could say that our is on ground here is false. Okay, before we test this, let's check if our ground is actually tagged as ground. If it's not, then we'll add a tag for ground, so it's correct. Okay. So our platform tile map, which will be our ground, is not yet tagged. So we will tag this. So add tag ground. There. So our platform tile map will tag it as ground. Okay, saving it, and let's see how it behaves in play mode. Okay. We haven't saved the previous values because we were in play mode, but if I remember correctly, that was in rigid body, we have gravity scale of 3, right? And then we change jump force to around 12. Okay, let's check. So if I press on space, it jumps. If I press, okay, we haven't gated the thing in the script. Okay, so you have to gate this one. So if is on ground, then we can add force. If it's not on the ground, then we won't add the force. Okay. Okay, so if I jump, I'm not on the ground, then I can't jump again. So if I keep pressing space, it only jumps once, and we only have the ability to jump again when we touch the ground. There. However, if we collide here, it's still stuck, right? But since there is no collision with the trigger and the ground, we can't jump. Uh, with that collision. It should collide with the trigger at the feet of our player here. Okay, but next we'll fix this, no, where it clings to the wall. It sticks to the wall whenever, well, we sort of apply force to the wall. Our player sticks there. We could do that with what we call physics materials. But since we are doing 2D physics here, we should also use 2D physics materials. I'll create a folder just to keep things organized. I'll say physics materials. Okay. I'll go here and I'll go to create. And then under 2D, because we're using 2D, right? 2D and there's physics material 2D. This will be used by your 2D colliders and 2D rigid bodies. I will name this slip for like, or slippery, whatever you can. And there are only two parameters here, the bounciness and the friction. We're more concerned of the with the friction here now in this case. Maybe we can reduce this to around 0.005. Not too small or not zero, because if it's zero, there is a chance, or not there is a chance. Our character might slip from time to time. Now, for this physics material, you can add this to our player, so colliders ng player ta, or the rigid body of our player, or if you want, you can also add this to the ground or to our platforms. For now, I'll apply it to the ground. So it's either you put it here in the rigid body or you put it in the collider. Since our collider here is being used by our composite collider, so the material for that will be in the composite collider as well. But you can also put it in the rigid body. It doesn't really matter much. But it just makes more sense to me to put it in the collider, so I'll put it in the collider instead. Okay? Put it here. Just drag this physics 2D material to here and there. Material slip. And then we'll see what happens when we bump into the wall. Okay, there. It's no longer slippery. Or it's no longer stuck. It slips down like so. Okay? Oops. Yeah. Any questions so far with jumping, physics, material, velocity, etc.? Nothing? Okay pa? Okay. Next thing we'll do is camera work. Since our camera right now is just static, it's just facing there. And if our player goes out of screen like this, it doesn't follow, right? So we can do this with a basic camera follow, like what we did with MP1 or like MP2 for a bit. No, MP1 rather, where we could put the orthographic camera to the player as a child, or we could have a script that uh, dictates that the camera follows the player, or we could have some more plugins that would do that. Our goal here is like the example that the camera doesn't really stay focused on the player all the time, where the player is at the center. What we want rather is that the camera sort of chases the player around when the player moves. For that, we will implement what a plugin or like an extension called CineMachine. So CineMachine implements sort of like a virtual camera, and it interfaces with our camera for the game. To do that, it's already installed in Unity, but you should install it again from project to project basis, right? If you install it in another project, it might not be installed in the project you're currently working on. But just to make sure, you can go to Windows, or Window here rather, on the top bar, Window, Package Manager, and then packages here should be Unity Registry. So anything that is within Unity. And then we could just search CineMachine. There. It says here install, so meaning I haven't installed it on my project right now. We just click on install. It will take a few minutes and it will recompile with the scripts and everything. And then after that, it's ready to use. Okay. Okay. Once it's removed here, meaning that's already installed, there's also a check mark here. Uh, so meaning we can now use it. First things first, I'll just create an empty here. Say, okay, empty game object. I'll name it camera. I'll zero out or reset that, and I'll drag our main camera as a child for this camera object. This is just for organization in the hierarchy later on. Okay, so the next thing we'll do, we'll right click on camera here, we'll create a child, and then there is an option here, Cinema Machine. So you have options here, like 2D camera, blend list. We'll be using a virtual camera. So a virtual camera will interface with our main camera and it will sort of control it. So depending on the behavior of our virtual camera, the main camera will be moving along. So I'll call this running camera because it will be following our player when it is running. So I'll say running camera. So I'll just zero out the position. Oops, never mind. Okay. And then there is a lens ortho size here. So it's basically the field of view of our camera. So you can decrease this to zoom in or increase it to zoom out, right? Maybe probably around 4 is good enough. But as you see now, it's also capturing the places where we haven't painted on the background yet. We'll fix that later. But I'll put lens ortho size here as 4. And then if we click on body, there are options here, transposer. Transposer meaning it just follows a game object wherever it goes. So we could use this transposer, but this is just sort of the same thing as like scripting, follow this transform, right? But what we want is something that sort of chases our player. So we'll be clicking on or we'll be using framing transposer here, framing transposer, and the UI for that is quite different as well. So it follows a game object, but it sort of chases the game object instead. So when the game object moves, it will move after it, like chasing after it. But to implement this, we need a game object to be followed, right? So there's a property here, follow, and it asks for a game object. So we want our player to be followed by the camera, so we'll just click on follow here, there, or drag our player to the follow here. It accepts the transform now, so it follows the transform. And then if we click on play, so it follows our player. Pero di ba, it's kind of smooth. It kind of chases the player instead. It's not where it's one-to-one straight on the player. Okay, let's look at some more properties here in the body. So we have track object offset. So if you want to offset the object, we have here damping. Damping is sort of the rate of change or the speed on which the camera will follow your player, right? So if I increase the damping, then the chasing will also slow down, sort of like this. Okay, like that. Maybe I'll put this to 1 instead. So if I zero it down, it chases directly. So maybe 1 is good enough. So here you can see the yellow dot goes out and then the crosshair chases it. Like so. Okay. Other things is we could also adjust the X and Y or where we want our player to be located. So for example, if you're running, you want your player to be around here to the left. So maybe around 0.3 would be good, right? And then Y, maybe you want it like around the top or around the bottom. That depends on you, but I think I'll just keep it at 0.5. Okay, like that. So it's running along like that. Okay, so it's sort of offset. And then we also have this thing where it is the dead zone. The dead zone has a width and a height. So if I increase the width of the dead zone, I'm not sure if you can see it, but there is a blue or light blue line that moves. That is the width of our dead zone. Now the dead zone is the zone where our camera does not follow our player. So inside this dead zone, as you see, the yellow dot moves in between the two lines, but the camera doesn't chase, right? But if you go outside, then the camera will start chasing you again. It's the same thing for dead zone height. No? If I put 0.2 here, so we have sort of a box where our player is not being chased by our camera. So if I jump there, 0.2, maybe 0.2 might be good enough for this. So our camera follows around like so. Okay, take note of the values. What we did was screen X is 0.3 and then 0.2 for both of our dead zones. If we exit our play mode, this will change or this will revert. So I will re-enter this 0.3. Dead zone is 0.2, 0.2. Okay, I'll edit our scene to have like more runway for our player, so we could have more things to do. So we'll go platform tile map and that palette here. I'll drop. I drop for this. I'll just extend this whole thing. Okay, that might be good enough. We'll also stretch our water tile map. Stretch it here and there. Okay. And then as well as our background. So I will disable the renderer for platforms for now. I can paint freely on the background. Okay, for the background, we'll do this here up here. Right? Okay. Oops. And this. And okay, that's good enough. Our platform looks like that. Okay, something. Okay. Oh, we'll add a bit more platform around here. There. Okay, and then we'll situate our player like here. Starts there. Okay. Okay. So let's try playing this again and just observe what happens with our player. So it runs around, camera follows it like that. But there are times when our camera like follows the player, and then there are things where it's uh, it's capturing these parts where we don't want the player to see, right? It's not painted yet. So we don't want to include that in the camera. So we should sort of prevent our camera from showing or panning into that location, right? These parts are okay, right? But if we maybe go too high, there, we could also see the blue there that's we haven't painted yet, okay? Oh, I'm trapped. Okay. Uh, then maybe just for testing there, right? If I move the player to here, Okay, and we'll go to the top. We could also see that weird blue background, right? Here, there. Yeah, we don't really want to see that, right? We want to limit our camera within some bounds. So let's do that next. We could do that with Cinemachine. I mean, we could do that with script probably, but easiest way is through Cinemachine and some colliders. Now, since we don't want our camera to pan over things where there's no background, we will limit the camera movement within the background itself. Uh, so to do that, let's go to our background first. I'll disable our platform and water tile map just for now, just so we could see the background, right? I'll make our scene bigger. And then our player, let's move it here. So we want our camera to be confined or to be bounded in wherever the background is. To do that, we could add a collider to our background. Um, we will be using a polygonal collider 2D because this is the one that our extension will ask for later. So polygonal collider 2D looks like that. It's a pentagon, but you can edit this. We could edit this roughly for now and then fine tune it later. So I'll just put it here along the sides. We'll fine tune it after this. Okay, we can then zoom in, right? Fix this where it's, you don't have to be too exact, just as long as it is like inside the boundaries. So zooming out, something here. Okay, stretch it to the corner, and the other one, stretch it there. Okay. There's another one at the middle. Okay, there, like so. So we want our camera to be bounded by this. So what we do next is let's activate our water and platform tile map. I'll situate the player here. What we'll do is under Cinemachine, or our virtual camera rather, running machine, we have this here, extensions. So we could do a bit of more functionality here. So let's click on select and we will be using Cinemachine Confiner 2D. So it's the confining box or like confinement or like bounding box of our camera. Our camera won't move past this bounding box. And then it calls for a bounding shape 2D. But this one should either be a 2D polygon or a 2D composite collider. That's why we select polygon, 2D polygon collider, right, for our background. So we simply just drag our background here to the shape, and there, then it's done. Okay. After that, your camera will not go outside of our bounding box. Okay. So if we click on play, our camera should not be able to go behind that. Okay, but there's another problem here. Our player, well, our camera is fixed. It's no longer like viewing the blue background, unpainted stuff. But our player just whisked away, right? The problem is that because we have a collider on our background, so that collider collides with our player because our player has a collision, right? Not good. So what we can do, we could review now. What can we do? Can we do it by script? Not really, because our script can detect collisions. But if you disable collisions, you might also be disabling the collider for the bounding shape of our background. What we can do, however, is to turn off collisions for some things, especially our background. We'll turn off collision for our background. Our background should not be able to collide with our player, with the platform, with the ground, etc., etc. Right? We can do that with collision layers. Looking at here, so background, there are two things here, right? We have a tag and a layer. So don't be confused with the layer here and with the layer in the renderer. So sorting layer is the way you would sort the layers in the render. So if it's at the bottom of the order, it is at the very front of the render. That this is for rendering. The layer here is for collisions. And the tag, well, you can do a lot of things in the tag, right? The layer here is for collisions, and this is what we're interested in. So we are adding a layer here. So I'll add a player layer as well. We might be using that later. And I'll add a background layer for our collision. Okay, and then the next thing we'll do, go to background and we'll select a layer here as background. I'll also select the player and layer it as player. But here, there, our layer, collision layer for our game object background or our background tiles is background. So it's different from tag, it's different from sorting layer. Next thing we'll do is we'll open the project settings. So edit, go to project settings. Here, we have a lot of things here, right? We're interested in the physics because physics manages the collisions, right? So you could go to physics, but this physics without the 2D is for 3D physics. What we're interested in, since we're using a 2D environment, we'll go to our physics 2D. Physics 2D has general settings like gravity, XY, default material, etc., speed, rotation. We don't really have to do anything with this right now, but if your future project calls for it, you can edit this. What we're more interested here is the layer collision matrix. And it says, it's just, there are checks here which just says that this layer collides with another layer. So for example, here our background layer collides with our default layer because default background, there's a check, meaning they collide. What we want to do is to disable every collision from our background. So no collisions on everything, no collision on UI, water, raycast, and well, no collision with itself as well. So there, no collisions on our background. Okay, so let's close this. That should be okay now. And then let's click on play and hopefully this works. There, our player stays in the screen. If we go here at the very side, oops, our player can still fall because there's no collider there. But our camera doesn't extend all the way to the side. If we go up, or okay, let's traverse this plane. If we go up, this stairs to heaven, there, our camera also stays in the confinement, right? There, good enough. There, our camera doesn't show the bits we don't want the player to see, and it follows our player in sort of like a smooth chasing manner. What's missing though, compared to the example I showed earlier, is that when our character or player is idle, it sort of zooms in, and then when we start walking, then there's like sort of like an action camera where it zooms out, gives you better field of view, right? We could do that with Cinemachine as well. What we'll do is no, not clone, create another Cinemachine camera. No? So I'll right click on camera, and under Cinemachine, I will click on state driven camera. So this will depend on the animation state of the target, which our target is the player. So state driven camera, I'll click on this, and then there. What happened? What happened is this state-driven camera has a another virtual camera. This one we don't really need, right? Because we already have a running camera, virtual camera. So I'll delete this, and then for our state-driven camera to work, it should have children because it will choose from whichever children is available. So I'll say running camera. I'll put it under state-driven camera as its child. So now it's the sole child of our state-driven camera, and we don't really have states. So if I just click on play, oh, we were in play mode, so I have to do that all over again. Okay, um, right click, Cinemachine, state-driven camera. I'll rename that. I won't rename that, rather. I'll delete this virtual camera and drag our running camera down there. Now, if we click on play, since there is only one child, there is no interchange. And we also don't have state. So it just behaves the same. Okay? Now we can create another virtual camera and set up its features, but let's take the easier way and just duplicate our running camera and then just edit a few features, right? So maybe I'll duplicate this running camera and then I'll just name this idle camera. Okay, I'll put it at the top. And then for our running camera, I'm probably going to edit the lens ortho size to 5, right? So now these two are all almost just the same, right? So for us to differentiate or for us to view whatever changes or whatever difference are between our idle camera and running camera, we can click on this button, status live. So we can click on solo, then that is the point of view for our idle camera. If we click on running camera and we click on solo here, that is the point of view for our running camera, right? Why is it in the bounding box outside? There. Pero we don't have states yet. So, yeah, we should implement that as well. So for our idle camera, so I'll click on solo. So when I edit the properties, I can see what I'm doing. Maybe I'll zoom this in. Maybe ortho size. Oh, I'll put it 2.5. Around 2.5. Very close to the player. And then for our running camera, so around like this, maybe 5, or maybe you can stretch it to 6. Don't worry if it looks like there is background here. It will be gone when we start the game. Okay. So idle camera looks like this. Running camera looks like this. Okay. Next thing we'll do is click on state-driven camera, and well, we want an animated target, right? And that target is, of course, our player. So we'll drag our player down here into the animated target. It will actually just get the animator component for our player. So if we click on player here and where is it? Animator, this one, it will only get this component. So we have our animator controller here. It has only two states, where the knight is idle or the knight is walking. We'll do more animations later on, but for now, we'll stick with these two. State-driven camera, our player animator there is plugged in. We have virtual camera children, which it will pick on, right? For us to have state transitions with the camera along with our player animator, we'll add some sort of transitions here. So state camera, wait a minute. List is empty because we don't have transitions yet. So we'll add transitions here, new state. I'll add two states, one for idle and one for walking, right? So if the state, this will choose between the states in our animator, night idle and night walking. So I'll say night idle here and night walking there. I'll make it a little bigger. And then if our night is in the idle state, we'll say that we'll use the idle camera. And if our night is in the walking state, we'll use the running camera, right? So when our knight here transitions to a walking motion or walking animation, our camera will also transition to the running camera. Sige. Let's play. There. So transitions and then transitions back. Very, very fast because we don't have wait times, right? So it's running, so it's transitioning to our running camera, right? And then if we don't have any controls there, idle state. There. So as soon as you press, it transitions. As soon as you release, it also transitions back. To prevent this, we could implement some wait times and some minimum times. So we can hover, let's click on play mode here. You have wait times and minimum times, or min here. Okay, I'll just click on play so we can observe what happens now. Our wait time here, for example, I'll exaggerate it a bit so we can see now. Maybe I'll put 3 here, so that's 3 seconds of wait time. What this means is this state will wait 3 seconds before it transitions towards the state. So if our night idle and our idle camera has 3 seconds of wait, when we press on our walk, it immediately goes to the walk because wait here is 0. And then if we don't have any controls, it waits 3 seconds, and then it transitions back, like so. We could also implement a view wait here, maybe right 0.5 seconds of wait. So it waits a bit and then transitions. There, it waits for 3 seconds, transitions, like so. Okay, this is 3, 0.5. There. Okay, so just to review our project here, our mini project here. We have player input, W and no A and D for horizontal input. We also have a running animation, flipping the sprite. We also have jumping. We have gotten rid of the sticky walls problem and no double jumps as well. And following camera and idle state and running state. So for now, yeah, that's it. Time is still a bit more time, so maybe we could do a little more. Maybe I'll just show the portal, no? Because I've shown the portal creation sa previous section. So I'll do a portal creation here as well. So for the portal, I'm not the best when it comes to VFX, but I try. We'll be using VFX for the portal. Okay, not VFX, particle effects rather. So I'll minimize this camera, clear. I'll create an empty object here. Yeah, that's pretty good. I'll say this is warp portal 50 3 0 there. Okay. And then we could put particle system right here, right then. But my my portal that I did, it has two particle effects. One where it sort of expands, one where it goes inwards, the black sort of background thing. But we can't put multiple particle systems in one game object. So we'll do two game objects that is the child of our warp portal here. So I'll create an empty object here. I'll name it warp portal in effects, like that. And then I'll add a component here, particle effects, particle system, there. Okay, so our particle system looks like this. So it spreads all over at the background because our renderer is not set to render at the foreground. But let's look at our system here. So the duration is 5, so 5 seconds ang whole animation. It's okay, I don't think we need to edit that. Start delay is 0, so it starts right then and there. Start lifetime is 5, start speed is 5. We'll edit this, start speed, because what we want is just one single particle, or the particle, it doesn't move, just expands in place. So it does not have a start speed. So I'll put 0 here, start speed. Right? Start size, we'll just leave it as is. We'll modify the size with size over lifetime later on. Rotation, no rotation. Gravity source, since we're in a 2D environment, I'll do 2D physics. No gravity modifier, since this is not affected by gravity at all. And then, yeah, for that, that's pretty good. Emissions, this is our, like, how many particles we are doing, or how many particles are being shot out at a time. I'll leave this for now, but we'll edit this later. Okay, shape. Next is shape. Shape here is the shape of our emission. But since we don't want our particle to be emitted somewhere else, and so we don't need an emission shape. We just want our particle to stay in place. So I'll just click off of shape here. So meaning no particle shape, or no emission shape. Okay. Next thing we need is the render so we could see our particle. Before that, we'll do size over lifetime. There, size over lifetime. So this is expanding, so it starts very small and then ends up pretty big. So I will click on size over lifetime. I could click on the graph here, and then there are parameters here. So it starts 0 and ends 1. If you want this to be a bit bigger, you could click on the size here and then drag. Maybe I want it around 3, there, 3. So it goes from 0 units to 3 units in size. Okay. Next thing we'll do is, sige, let's go to the renderer. So for the renderer, we want it to be rendered sort of in the platforms, I guess, as well. Just at the front of our background. So for that, we'll render alignment, sorting layer. There, sorting layer, we want it same as platforms. It's not rendering right now because we don't have any material to render, right? And it will depend here sa material. We could also change this to sort of like mesh, and there it looks like that. It's the purple blob. But what I want here is billboard, and then we'll just plug in something in the material. Material is sort of like texture, right? And we'll create that material here. So let's go to assets. Uh, I already have this PNG. This is just a PNG picture, right? If I open this, right there, it's just a PNG picture. It's just a white circle with glow. This is very much easy to create. No, this is just a 100 by 100 pixel na photo. It's easy to create. If you have Photoshop, I think you could also do this with Canva, right? Just have a circle and then just implement glow. That's and save it as a PNG. And then we'll use it as a material. I'll create a folder just to keep things organized. Yeah, visual materials. Okay, and I'll drag this circle to materials. And then we'll create a material out of this circle. So right click, create, and then material. There. Okay. I'll name this warp. Warp portal. There. And then there are a lot of things here. Again, I'm not an expert on materials and VFX, but the one I used is shader, mobile, particles, and then additive. Okay. This asks for a texture that we want. So we'll just add your circle here as our texture, and then for our warp portal, we'll add our warp portal material here, and then there. It's like white hot and glowing. It emits very fast. It's throbbing like that. So we could tone down the emissions, maybe 5. 5 is still a bit too fast. Maybe 1 emission there. So it emits 1 particle every second, and that particle goes outward. Not really outward. It stays at the middle, but it expands in size, right? Okay. We can edit as well. I will also edit um, color over lifetime. Okay. I want it to be color over lifetime, so I'll check it here. So I'll put one here, one anchor here at 33, and one anchor here at 66. Okay, what I want to do is at the very start of its lifetime, it is transparent, and then it goes opaque, and then it goes transparent again. So something like that. At the middle, it's very, like, you can see it clearly, but at the sides, it's fading. Okay, we can edit the color of this. So the color I used was like purple, right? That maybe purple like that, but it's a bit sort of what do you call this, it's faint. It's also sort of transparent because that's the nature of our material. So we can add another portal here or another particle effect that is sort of like going in background darker, a lot darker. So I'll just clone this so I don't have to do all that work again. And then instead of portal in, I'll do portal out. Okay, I will edit the size over lifetime. And this one, I want it to be from something big and then go small. So it's like inward, right? But the color or the renderer will also be different. So in this case, I want to create another material here. I'll call this warp portal dark. Okay, and we'll use mobile particles, and alpha blend. Okay, we won't do a texture here. Instead, I'll do a mesh instead. So instead of billboard, billboard is if you have a texture, right? It will just slap it in there, paste it like a billboard, right? What I want is a mesh, and instead of a cube here, I'll do a sphere. So it's like a sphere that goes in like that. Okay. Okay, color black, renderer, warp portal. Okay, so the material should be this warp. Where is it? Warp portal dark. There, it's much darker. I also want to edit color over lifetime. I want this to be a bit more. Um, there. Put a little alpha there. Okay. Yep. Look good. So we have like a dark going in and then like a bright going out. We could also do things like, or you could do like 1.5 emission, so it's a bit faster, like so. Or you could have bursts. Bursts would look good here as well. Maybe you have this and then just yeah, 30 means 30 particles coming in or coming out at a time. So that's why the burst looks like very thick. So you could have that sort of like pulsating thing. And then you could do intervals of say 0.1, so it's a bit thicker as well there. Then you're free to tweak whatever you want here in the emissions, but yeah, that makes it look a little like that. Okay. If I click on play, let's observe it when we're in play mode. This doesn't have any functionality yet. There's no triggers, there's no code. It's just visual effect, particle action. There. Yeah. So the portal looks like that. If you jump in the portal, nothing happens. Yeah. You could also do this thing in the portal. There is pre-warm because if you start, let's move our player so it starts around the portal so we can see, or we could just move the portal instead. Why not? There. So if you click on play, it's like it's going to have a bit of time before it forms, right? But if you click on pre-warm, pre-warm like that, whenever you click or whenever you play, it's already doing its thing there. Pre-warm only works with looping animation, so it's sort of like um, gets like a snapshot when the portal or the effects are fully on display. Yeah. Then you could do some functionality with this. So if you want sort of like a trigger, where if you go into the radius of this portal, it goes to the next level, etc. Yeah, we'll do that. Like, we'll do multiple scenes next time. It's Monday. Yeah. And we'll do a bit more like dashing and enemies and player mortality, like when our player dies, right? Any questions? Okay, you can end the lecture here.